Hello everyone, I'm Brandon Canaday, the Chief Product Officer at Losant. In this video, I'm demonstrating an IoT application that uses image analysis for quality assurance. So think about a camera connected to an assembly line, and images are captured by a technician or as part of an automated assembly process. We built this application to specifically show how Losant makes it easy to build real-world applications on top of the AWS catalog of services. AWS is extremely powerful, but still requires significant engineering time when it comes to connecting services together into a final application. Losant's drag and drop visual workflow engine solves this orchestration problem by providing an intuitive and low-code approach for cloud development. But before we get into the implementation, let's take a look at this application. When a technician clicks the capture button, a camera connected to an AWS IoT Core device takes a picture, which is then sent to AWS Recognition for analysis. In this example, we're using the pre-trained object detection model. If there's a spoon in the image, it's marked as a defect. If there's no spoon, it passes. In an actual QA environment, you provide AWS a model trained to identify defects specific to your assembly process. Lastly, we have a table that stores the history of all captured images and their defect status. On the surface, this seems like a straightforward application, but there are 5 different AWS services and a web application that all must work together. When the capture button is pressed, a message is queued into SQS. From there, a command is published to the device using IoT Core. When the image is ready, the device publishes the raw image back to IoT Core. The image is saved to S3 and sent to Recognition for analysis. The analysis results and the S3 image location are queued again into SQS, picked up and saved into RDS for the history, and finally sent back to the web application so the user can see the results. What you'll see in many AWS architectures is a bunch of Lambda functions connecting these services together. Each function is typically doing a small amount of work, mostly reshaping data. For example, taking the output of Recognition and building a SQL statement to be inserted into RDS. Lambda functions certainly work, but they require code and obscure the connections between services, often making it hard to know what's talking to what and in what order. This is where Losant's visual workflow engine excels. So let's dive into the implementation and see how easy it is to orchestrate these AWS services. Starting with the web application, when the user clicks the capture button, this makes an async callback to the web server. In this case, we're using Losant's end user experiences, which is an entire web application development environment built directly into the platform. I'm not going to cover this in great detail, but at a high level, experiences are made up of endpoints, workflows, and pages. When the button is pressed, it's requesting the /API/capture endpoint. Whenever that's invoked, it triggers the corresponding workflow. If you recall from the diagram, all we're doing is queuing a message into SQS. The message is capture, and we're adding some context to the message attributes so we know how to respond to the request later. So now we have a capture request message in the queue. The next step is to subscribe to the queue, receive those messages, and take appropriate action. Losant can directly subscribe to AWS SQS and trigger workflows whenever messages are received. Here's the workflow that's triggered whenever a message is received from SQS. It's handling both the capture request and capture response messages. For simplicity, I've combined both of these into one workflow, but you can just as easily have separate workflows handling separate message types. When a capture request message is received, we're publishing a message to IoT Core that instructs the device to take the image. We can see this happen in real time by opening a terminal to my IoT Core device. When I click capture, we can see that the device almost immediately receives the request and captures an image. A few seconds later, the resulting image is displayed to the user. So with just a couple of workflow nodes and zero code, we've successfully connected our web application to our IoT Core device. But now we're to the interesting stuff. Let's see the workflows that handle the image data being sent back from the device. Just like with SQS, Losant can directly subscribe to IoT Core. This is the workflow that's triggered whenever a message is published to a specific IoT Core topic. This workflow is doing a bit more work. We're base64 encoding the image and generating a unique ID for this specific capture. Next, we save the image to S3 with the unique ID as the file name. Once the image is in S3, we can invoke recognition, which accepts an S3 location as an input. Not every object in recognition supports a bounding box, so we want to filter the results. This is also a good example where sometimes code is required, and Losant's function node allows the developers to use code whenever necessary. Finally, we publish a capture response message back to the queue with the image name and the labels that recognition identified. From here, we can return to the workflow that handles SQS messages. We're now checking for defects. Is there a spoon in the image? Inserting a row into our RDS Postgres database, and finally replying to that original async callback that kicked all this off. That wraps up this demonstration. We've barely scratched the surface for what the Losant platform provides, but you can see that when it comes to orchestrating cloud services, the Losant Visual Workflow Engine provides an ease of use and time to market that is hard to beat anywhere else. Thanks, and stay connected.